and they filmed this Baldwin Hills Reservoir event, and the event showed them trying to block off the small hole in the abutment with the sandbags, showed personnel working in the area, showed probably people trying to drain the system.
It's going out probably through 75 feet of earth fill.
As police were called in to evacuate the area, word got out there was trouble at the dam.
I remember it being a Saturday morning. I was in my room. I was 17 years old, and I remember hearing a news report on the television in the living room that there was a problem with the Baldwin Hills Dam.
Richard Levine was a student photographer about to document his first big story. Grabbing his camera and a few rolls of film, he raced to the scene.
When I got down there, it was absolutely amazing. It was the most chilling sight I'd ever seen. I mean, to this day, I still think about it. Chills go down my spine.
To the horror of the city workers gathered at the site, in about an hour, the rushing water eroded the dam's concrete abutment from below, turning a pencil-thin crack into a 75-foot-wide gash. When the abutment crumbled, 292 million gallons of water surged out of the reservoir.
A large chunk of the inner cement here in the...
This water was tumbling and rushing and boiling, and it was just washing homes out.
There's a picture. You can see those automobiles literally being pushed back, then went over the top.
It reminded me of the Great Gorge of the Colorado River. And I shot until I eventually ran out of film.
When it was over, 65 homes in the path of the flood were ripped apart. Hundreds of other structures were damaged, and 5 people lay dead.
I hadn't even seen the worst part because I was up at the top of the dam when it washed out those homes. They were just gone. There was just foundations left. It just wiped them out.
City workers drained the rest of the water from the dam, and homeowners were left to sort through the wreckage. Engineers went back to the original plans to learn what caused the lining to fail, fatally compromising the dam. They discovered that the failure could be blamed not only on how the dam was designed, but also the location where it was built. The Baldwin Hills Dam was constructed 400 feet from a large fault line. Smaller secondary faults ran beneath the dam. If any of the faults were to shift, the lining was intended to flex with their movement. In this way, the integrity of the dam would be maintained. But that's not what happened on December 14th. This puzzled investigators because they knew the dam was built with the existing fault lines in mind.
The designers attempted to deal with this, although they vastly underestimated the magnitude of the movements that would occur across these faults in the operational life of the reservoir. They realized the faults were there, but they underestimated how much movement would occur across the faults.
The lining was made by putting down a layer of gravel, followed by a 1/4-inch thick layer of asphalt reinforced with cotton fiber. But when the faults moved, this material proved to be less flexible than designers may have wished, and it failed. Underestimating the potential for fault movement was a fatal error. But what had caused the faults to move more than the designer expected? Investigators determined that other hidden factors were at play.
This bowl, the Baldwin Hills Reservoir site, is on the eastern edge of the Inglewood oil field. Inglewood oil field is probably about a square mile in area or more, and it has about over 600 wells at one time.
Pumping oil near the dam might have caused the land to become unstable and thus stimulate fault movement. But the oil companies were also using a method of oil extraction that raised a red flag. The method was called pressurized extraction.
The process is to eject water under high pressure, and to cause that water to and oil to push towards the active wells.
The pressure extraction process involves pumping millions of gallons of water at high pressure beneath an oil field, which forces the oil toward the surface, where it is easier to pump out. The extraction method apparently built up great below-ground pressure.
I did go out to one of the repressurizing wells, which was south of this site, and looked at the gauge on the well itself, and it registered 600 pounds per square inch. That was on top of the ground, and the well was either 1,000 or 2,000 feet deep. So you can imagine the pressure that was being exerted on the ground, which eventually caused the separation of the bottom here.
Experts speculated that this intense pressure could have contributed to destabilizing the faults beneath the reservoir. But in the end, authorities could agree on no single condition that would have caused the dam to fail. Rather, a combination of factors: fault movement, spurred on by oil exploration, and brittle structural elements in the lining of the dam, acted in concert to create the disaster.
Well, the fact that they didn't have an adequate review process during the design of the reservoir and its embankment led to a situation where design flaws were not captured.
The Baldwin Hills Dam was never rebuilt, and after the reservoir was filled in, the land was turned into a park. Now only a serene hilltop marks the scene of the disaster. In part because of Baldwin Hills, dams built near fault lines now receive special scrutiny, and peer review is mandatory for all public works projects.